So yeah, welcome back. At least what we're going to learn today is actually called assignment operator. Now, yesterday we have learned about what is called equal to, which is what we use to assign a data to a variables. Now, what we're going to learn today is going to be other operator that we use to assign, especially in mathematics. Let us assume we have what is called y is a var of integer. Int y is equal to, let's say y is equal to 10. Then now I want to print y. Now it's easy for me to just say, okay, I've said that, compile, I just copy that. Now you see what I'm doing now. I'm trying to go or by press arrow key up so that it gets all my history of command I've typed. So I've compiled it now. I can just basically just run it like this. So you can see my y is 10. It's okay like that. Now let's assume I want to add 5 to y. Now if I want to add 5 to y, I need to say y is equal to y. Yeah. So you might just say y plus 5. This is not going to work because this is not going to affect our application in the memory. It's not going to affect our application in memory. It's just going to run like that. Assign 5 to it. So look at what it's it's still the same thing. Let me compile it again. So it's still the same thing. It's still the same thing. So what we can do, or what we're supposed to do to make sure that it's increased, is to have what's called y is equal to y. Now I'm assigning a new y to it. That's what I'm doing now. But what I'm trying to do before, I'm going to just plus a values to it. So the y is not aware of this value. So I need to have what is called y is equal to y plus 5. So y is equal to y plus 5. And this is going to assign this is going to make us 15, because now what I'm saying is that I say a new y. I told that in memory they usually create a new data. I get in. I'm saying a new y is equal to the old y that we have. Then I'm adding 5 to the y of our new y. That's why it can actually update itself. Now, writing this kind of logic is actually like a long way to write a program. Now, how does that allow us to use what is called assignment operator to assign a value and add something? Now look at this operator. This is what's called plus and equal to. And this one allows you to add and assign a value to automatically. So like before, you're having y like this. What I just need to do is just I want to go y, my y data, y, and what I was called plus equal to then 5, like this. Now this is going to create take what is in memory plus and assign. So what you're going to do, you're going to plus this 5 and reassign it to the variable, the one that you have already. So that's what it's going to happen in the memory. And let's just add 10 to it so we can see that it's different. We compile it and we add it. So can you see it's not 20? So also we can also do subtract. I can say and 1 is 20, and I was called y. Again, subtract. Then I want to remove just 2 from it. I'll print y again. I'll compile it. I run it. For instance, 18. I have minus something from the y. Now let's have another thing, which is asterisk. So we have what is called y times, now that is 18 now. 18 now times 3. So now I cannot say 18 times 3 like that. I'm going to have what's called equal to like this. So I'm going to reassign it to the y. So the answer to answer is 54. And if I divide it by also 3, I can say F Y divide sign, then it's equal to, let's say 3 again, need to go back to 18. Print Y. Yeah. What happens is that after division, anytime you divide a data or you divide something, it's going to return back to you what is called a string. And that's why we're going to have error, because this guy is going to become is already an integer. You cannot assign it to become a string. So what we can just do, no, we can't do this. So this, we cannot actually do this like this, because this guy is a string. What we can do is that we can change the value from integer to num. So num can take any kind of data. Num can take any kind of data. So it's a data type that is called num. So it is data type. It can either be int or double. So from here to this place, it's going to be integer. But when you get there, you return to double. So we can also say dot runtime. I want to see now. So there is num value that you can see from here to this place. So what num is going to do, one is just like a type that take the data, that can take two kind of data, which is double and an integer, but it knows the data type. So when we notice, when we are still here, it's still integer. It's aware that it's integer. But when we get there, it changes to double. And we check this thing, I going to change to double also. It's not going to call itself num. So it's going to use the real data type that I taught you, which is num and double. But it can actually take both together. So if you look at it, you can see this place it is integer. When you get to this place, it's now double. They change, but it knows the data type. So that's what I want you to be aware of. So we need to leave it as num. So that's how to use what's called assignment operator. So assignment operator allows you to update a variable effectively by combining an operator with assignment. So we use an operator with your assignment and make it work like that. So this is the sample code. You can copy it. And what is the use case? We use it for counter, money calculation, scores, and data updating. So let's look at what is called a introduction. This is a list. And what is list? List is a collection of data. List store multiple value in order, like an array in other language. So other language they call it something like array, but in this way we call it list. Okay, now let's have what is called a list. So what I'm going to do, I'm going to clear all this. You already know this. Let me leave it. So I'm going to come back here and have my list. I want to have what's called list like this. List, I say names is equal to, then I will have what's called Ade Malam. Now, as we have known that list or an object is a if data, they are stored in if storage. That was Ademola Salvation and zero. So now this is list, and this is how we call a list. Now let's look at what we can do. Now we can access a list by their index. Now, what does that mean? What that means is that list as seated or they have what is called index, and their index start from 0. So to actually access this what's called Zoe, we need to have what's called 0, 1, and 2. So what we need to do is what's called print name according to what? According to 0. We say 0 is going to give me Ademola. So I need to compile it. Then I will run this. So can you see? Yeah, it's giving me Ademola. Next thing we need to do, I say print names according to what? To compile, and I will run. The next thing we can also do, we look at print like this. Now, if you try to access a value that is not in the range, I'm going to have error. Let's say we access 3, we're going to have error because it's not in the application. Compile it. You know, the notes have so we're going to have error here. We have the available, this is not there. And what is here? What is showing us? So this is stack trace that show where we have the error and how it happens. So this actually makes a good sense to us. So we don't have what is called index 3 instead of this value, so we cannot access it. That's good for us to know. So then another thing, we can also print all of the data. We open all of the data, print names. So let me compile it again and let me run it. Compile it. Let's run it. Yeah, once you have print all of the data. The next thing you need to do is to learn what is called list method. These are just basic method that we are list out before we continue. We are going to just learn this basic method. We will learn about other methods when we get to when we have learned functions later. So first thing you need to do is you need to have what is called a list. And to actually use this to actually like access this guy on our object here, we need to call on the reference, use the list, and say this list is a list, then where was it called add. And what do we use add to do? We use add to add a data into the value. So I'm going to say, okay, this my value is going to have what's called my Iowa. So if I add my Iowa to it, if I run it again, compile it, that's it. Now, if you notice, nothing happened to it now. Yeah, nothing happened to it, but something has actually happened to it because we are not printing it. Yeah, that's why we cannot see what is going on. So what has going on? What has go on is that this thing has been done in the background after we print this. So you cannot know what is actually happening. So we need to print it after we add the values to it. So let's compile the application now. So now let's try to do name.insert. And insert allows us to take a solid data inside where we want it to be. Now I'm inside to index 0 and I put Badmos there. So let me compile and let's run the application and see. So the Badmos is going to be at the beginning because I have inserted it inside the index of 0, which is the beginning. Now my y is at the back, which is I just add it. Adding is going to add it at the edge of it. Now I want to remove salvation from it. So now compile and run, you see that there won't be salvation in it again. Can you see? Now I can also remove at specific index by saying dot remove at. So now I want to remove the index 0 now. I'm going to say 102. I want to put 2 there. And I run it again, compile it and run it, and say the 0 is not going to be there again. Now we can check the length is empty. I said the length. And what is length? Length is the count of the value, not the index now. It's the count of the value. I can check. I'm checking the length from the upper, going to give me 5, and the last one going to give me 3. But after I have removed it, it's going to give me 3. Now I can also say, is it empty? The print name dot is empty. It's going to be false because it's not empty. Can you see it's false? Now it's 5, false, and true. It's not empty. It's not going to be true because it's not empty. So let me compile it. So let's say name.contain. Now, what contain? I want to check, does it have what's called Zoe now? You want to give me false. Why? Because I've already removed Zoe from the list. So let's say give me false. So name.join. I said name.join. Now join is going to join everything together. I'm going to work together to make them a string. Now let's see how it's going to look like. Compile it. Now you can add space to it. Like space like this. Compile it again. So we have, and that thing that we have here is what is called print name dot first. And this is going to get us the first value. Let's compile it. Let's run it. And you first. That one called last. Print name dot last. Let's compile it. Okay, let's run it. Okay. So another thing we need to look into is print again. Names dot down. You have is empty. You have one time. You can say one time. So if you compile and then run it, to the runtime of it, they give us list and dynamic. So this list and dynamic, we need to look into that. So let's look at this list and dynamic. There is a different kind of data that we can dynamic. First, what is dynamic? Dynamic is also a data type, and we have to look into it with what is called var. Var and dynamic, they are both data type, but they are different. So let's look at what's called var. Var equal to var and say x equal to now if you look at var x equal to a, and this makes sense because what happened to a is that, or x is that, it takes the value, let's see, and they call it string. So what happened here is that anytime you create a variable with var, it's going to look at the value that you give to it and take also the type of the variable at the runtime automatically. So as soon as you take your var like that, if you try to assign a new variable to var, like we can do, we can just say var is equal to hello. It works perfectly fine without any error. But if you try or attempt to assign a variable that is not the primary type, maybe you assign an integer to it, you're going to have an error because you said the value of int can't be assigned to the variable of string. What that means is that this guy is aware of the type, even though it is generic. It can take different kind of type. Let's assume that we have what is called I can say I have 50. You also take 50, and there is no error. If I try to assign integer string to it, there is going to be error because string can be assigned to a type of int. So now, what does that mean is that any value you give to this at the first time or at the initialization is going to take the type also with it and run with that. Every time you want to assign any value to it, it's going to tell you that, oh, I have type. The first person that initialized me has given me integer, so you cannot give me string again. Now, you can't even give it double again. You can't give it double again. You can't give it double like dot something. It won't happen. You rather give it double first before it will work. So let's look at the main topic that we want to look at, which is dynamic. Dynamic is actually a dynamic data. Let's say y is equal to hello you already have y. Let's say okay, and we know it is very normal for any data should be updated automatically as soon as we have what is called it's very normal for any data to be updated as soon as we have the same data. So it's very normal for it to work like this. But dynamic does not care about data type. So if I say that now my k is not going to be I again, or not going to be string again, I want it to be what is called integer. Dynamic is going to take that. So dynamic can take any kind of data. So if I print it now, print k dot runtime, I say print x dot runtime. Let's compile it. Let's run it. Look at this. Now, look at what happened here. The first value is what's called double, but it actually get the gun time of this guy, which is the one time is double, right? But the issue now is that actually the value is actually initialized with string. Why? Because someone changed the one time back to integer. So that's how dynamic works. Dynamic can take any kind of data. So any data you give to dynamic is going to work. So that's what how dynamic work. And another thing I want you to note about this list and dynamic that we have here, or we had here, is that this dynamic that is here, this list that is here, is already designed as a list and dynamic. What does that mean is that this guy can take both 70 and true and false, even at 90.9 as a data, as long as we have common like this. So this is going to work very fine with our data. This is going to work very fine. There is no error, everything works because the list is actually list of dynamic. That makes sense. But what if you want to have a set of group, that is actually statically typed? It just wants to always give it its type. What if you want to have a list that have a specific type? So what you can do is that you will declare the type from the list like this. So we have two ways to declare the type. Now you can declare the type like this from the list like this. Now, say the type is going to be string. Now this is actually is good, but the issue we have with this is that with this guy is that if you attempt to add another data like this, a name, that's a still list of dynamic, because I can still add under this 7 to it, and that's going to be under error entirely. So it's not good for you to have a data like this. No, it's not good for you, but you can actually have it that way, but it's not good. So another way you can have it is to have it inside your list. So now how do you have it? You can open on this and see how it works. You can see list. Now the children type is actually what is inside of less than, greater than. I want what's called less than and put what's called string, then greater than. Now we need to remove this. Now if you attempt to add number like this, it's going to reject it for you that integer can be assigned to a type of string. So I can't assign it because it is string. So I need to remove this guy also and put what is called a string there, which is 7. So that is what we call giving a type to your list. So I may need to compile it and run it. So let's go to our notes. So this is our use case. You have downloaded this one. So use case of that is to store in collection of data when you want to add a lot of data, to manage list of users, product, score, or integrating through multiple items. That one you use what's called. Now what is dynamic? We look at dynamic before. And then dynamic is a keyword. Dynamic keyword in that the dynamic keyword is so powerful feature that allow a variable to hold the value of any type, unlike var or explicit type declaration. A dynamic value can change its type at one time, offering maximum flexibility. So why dynamic value? Why flexibility using dynamic value? It can reduce compile time safety, as type check are largely deferred until runtime. This will potentially lead to error and will otherwise be catch earlier in static typing. So these are the type. We have done this one. Okay, var versus dynamic. So var type declare from first value. You cannot change the type later. It's saver and it's compile time checking. So anytime you're doing it, it check it compile time. But in dynamic, the type change anytime. That check error at one time. So it is when you are running your application, and that attempt to check the error. So less saver, but it is more flexibility. Difference between the two is that var lock the type after the first assignment, and that dynamic allow any type at any time. That is the difference. So var will actually lock in the type as soon as you assign the data. That var will lock the type. You cannot assign another type to it. But dynamic allow any kind of data, any kind of type after you have assigned it. So let's move on and check what is called map. Let's check what's called map. So map is actually a new type of data that we need to learn. Map is actually a key and value data. If you look at it, map store key value pair like dictionary in other languages. Each key map to a value. So let's look at it here. So let's look at what's called. I'm going to create a user as it is in the application. Now we have what's called a map keyword like this. What's called user. Then we have equal to something like this. So the keyword of map is actually curly braces, but the keyword, the way you create map is curly braces, and the way you create list is square bracket. The curly bracket and square bracket, they are different. The first thing we need to look at now is the key. So let's assume that I have a key called name, and then we have what we call colon here. I will give it a value which is Adem Mala Oluwa. So the key and value now currently is that we have a map. The key is actually user. Then let's print out the user. So now I'm going to run it and say compile it. I run it. You can see we have the map key and value, and the type of this one is string. You can see one time is list of string. Okay, now the main thing that I want us to look at right now is how can we access a value inside of a map. So that's the value of the map. We use what is called the key of the map. So now what is the key in our map? We have a name key. So now we are going to say the map, then you have what's called the map, then you have square brackets. Inside the square bracket, you now put your key inside. That has to access a specific data in map. So another thing that we can do is to actually add more data here. I will say age. Now this actually really makes sense. Another thing we should note about map is that how it differ from list. So a list, you can actually say that you want to have a list of name of students. It actually makes sense for you to have. You have Ademolas, Salvation, like that, put them together like that. But when it comes to map, you cannot have two key. You can't say another name like this. No, you can say, also say name 2 or student 2, name 2 like this. I guess, but you cannot have two key to use to be in the same map. So I say colon, then I will have that thing called maybe manual. So this is not allowed. You can't add student 2. Oftentimes, map should hold a collection of data for a specific data. Let's assume that the where this thing is really useful is when we have a user like this also. It makes sense like this because a user have different kind of data. Like we have a list of data that belongs to them. Now we use map to actually organize all data that belongs to a specific user. So we can have a list of map that have a list of users that have a lot of data. So now we have a user now, going to user, then we have what's called name, the name of the user, then another thing that we want to know what's called age. So that's going to take a 18. Then we have another thing called this is scores or just score. This is score up 100. Now this makes sense. You can also say gender. Gender, then I'm going to have male. This really makes sense. Now this is for my good formatting now. So this is actually our map. We have created a map. So I can also do it to just compile it again and run it again. So guys, we have our map. So we can also say, oh, I want to print the age. I say print user according to age. So that's what I will be saying according to age. So like saying according to age, I'm saying the parental the square bracket, the age inside of it. So if I run it, it's going to work. Can you see we have what's called 18. So that's how to access a key. Now you can also you have a lot of methods that you can also use. So Abi, that's what's on okay. You can get all the keys by saying user.keys. You can also say you can get all the values. Print user.value. Can you see we have all the value here? All the keys, sorry. Then we have all the value. We are going to have all the value now. And we can also add to it. As a user dot add. Now because I have add, just want add. You use what's called add-on. So you want add-on, you have like this, you have put everything like this. Then you need to say, okay, I want to add new thing. I'm going to say father name. So mother's name. So now if I try to have like this, if I on it now, can you see? Now we have added this. We can't see the value now because after we added, we have not printed it. I can say print the user again. So you're going to see that you need to have some specific data. So we can also remove. I can say user dot remove. Now you put the key there to remove the value. So now I can say I don't want to say anything like score there again. I say score. I print it again. I see that the value has been removed. And I also remove the user that remove where, but this is a function. I'm going to learn that one data. The function takes a function, so I'm not get to function. So I can also clear everything that I don't want everything again. I want to clear it. Also, list also have a clear functionality. The names dot clear. And as a print names. So when I try to print the user again, I won't send it there again. So you can see nothing is there again. So we can also check if it is empty. Now let's say it's empty, it's going to be true. It's empty, it's true. But from here, print. Before I will check this, print user dot is empty, so that means be false. But now after I clear everything, it needs to be true. Also, we can also do is not empty. It's not empty. So can you see? It's empty, false. It's not empty, true. Data is there. I remove it. I ask again. There is empty. It's true. It's not empty. So that is what you can use. It's empty. You can get the value, get all key, get all value. So let's see more example. You can see more example here. You have score. Now look at this example now. It really makes sense here, and I want you to look at it. You have a score map here. The score take what's called the name of the student and give the score in front of it. This is a good way of using map. So you can remove charts from the score. You can check if it contains bulbs. You can check the reassign a data. So let's look at how we can add a new data with just saying, after we are clear, I say user according to new name. Now I can add this and that entirely. I will say GPA is equal to 5.0. And the value is going to be false now because it has the value now. The print user. Oh, sorry. I've now compiled it. We can assign a value. The way we add value like this, we add that value like this, we add, where is it? We add all like this. We can also assign a value like this, but it's not done with the list. Now this is going to take the map, look for where GPA is. If there's no GPA, you're going to add it there and assign the values to it. Can you see? But if there's GPA, you're going to reassign it. That's what this guy does for us. So now the use case is storing user profile. You can use the software, use the store configuration settings. You can map IDs to names, like give IDs to a specific name. To use it also to store structured data. So like you have key and you get the value. Your key and you get the actual value. That's what you do with this. So let's move to the next page. Now we are going to the next page, which is called input and output in that. So but we actually love to create a new file or to clear this one that we have. If you are typing with me, it's actually okay, I can clear it. So if you are watching the video, if I don't type, you're not doing yourself well. So I will clear everything, or let me create a new file. I will say main 2. That does it make sense? And let's do that. I will say void and main in that. So let's read the document. So that program can interact with user through the console by reading input and displaying output. And number one way we should look at is the important input and output work in terminal environment, not in Flutter application. So as you are going to be learning Flutter later, input and output does not work in Flutter. So you use input and output in the terminal project or your console project, in your backend. Your backend said you use even HTTP to communicate with your backend. I want to get there very soon. So let's look at what is called input and output. Because the number one thing that we need to learn is the simple ways of creating output. Is that we have what is called print. So let's see. Welcome to that. I can also say print hello everyone. So I said hello everyone, welcome to that. This is actually good. Now how can I run project that is not main? It's just the same thing. Just want to change the name to 2 like this, and then to compile this for you. So guys, we have 2.exe. That's what it's called. Now when you want to say main, then 2 like this, exe. So you want to give it, it has given the data. That's cool. So that's what I want to use. So just say compile the name, put the name in front of it, and that's all. And do the compilation for you. So now we are actually like inputs into this. Now we can output. There's a full functionality, something called std out. So we can output with that, and that is actually this guy. You look at it, that's what it does for us. And the print is a function, so it takes different kind of output and it prints it out based on your operating system, or where your application is running from, based on your runtime. And if you want to actually let you know what you are doing currently is only on your terminal, your console application. You can actually use what is called stdin. So what I want to input something. So now what am I input and why am I input something now? Now inputting something into that file is because what I'm currently doing now, what I want to currently do is not a default inside a DAT file. So all these guys, there's no need for us to import anything automatically. DAT understand them and they work automatically. But this guy that I want to import, I need to let my file to be aware, or my compiler to be aware, that what I'm doing now is not, you might not actually know it automatically. But if you check into this my package, it's called packages. If you check into this package, you're going to see what I'm writing there. So what is package? Package is a program that is written by other people for you to use in your DAT file. So that IO is called that IO, which is called input and output. That was the full name. That IO is a when I say IO support non-web application also. So that IO, you can use that IO for file, socket, HTTP, other IO support for non-web application. I want to learn all these things also in our application. I want to learn everything, most of everything that is there in our application. Now look at this guy that is here. Are you with me? So that IO, this is where we get our data that we are actually talking, we are want to use from, which the data is actually STD. I want to say STD